Yeah, good morning and good evening, everyone. So we completed 2 sessions on Terraform. Yesterday we discussed variables and then we discussed conditions. You know the condition syntax here. It is expression, question mark, and true statements, colon, false statements. So this is the conditions simple syntax. And then later we discussed count and count index. And then later we discussed data sources. And later we discussed locals. Okay. Yeah, so this is what we discussed, and then outputs also. You know variables and data types very well. So we have string, number, bool, and then list and map. Conditions, this is the condition. Count and count index is part of the loop. And data sources is useful to query the information from the provider. For example, if you want the AMI ID, if you want the VPC ID, ideally you can query everything from AWS using data sources. And then locals, this is a special type of variables. It has some extra capacity. You can run expressions and functions in local. Okay. And there is one more advantage. So we will discuss anyhow. And yeah, so outputs is to print the output onto the terminal generally. So these are the things we discussed. So today we will continue with the loops again. So this one, count and count index, this is also one type of loop. Okay. Mostly we will iterate on list. So mostly it is iterate on list. So now we will discuss another type of loop that is called for each. Okay. So mostly we use this for a map or can use for list also. So this is one more loop actually. Okay. So we can create a use case for that. Let me create for each. So at any point of time, if you have created a new Terraform, you have to give provider.tf. That is the first task you should do. Copying the content. Okay. Terraform init. It will initialize. So now what is the use case we will discuss here using for loop is okay, let's create instance. Let's create 10 instances using for loop. Okay. So yesterday we created instances using this count parameter, right? So here we have given count equal to 10, and then we got the names from this one variable instances. Here we have given the list of instance names. So on this, we are doing it for 10 times. And then, yeah, if the instance name is MongoDB, we are creating t3.medium. Otherwise, t2.micro. Similarly, we created records as well. Okay, so today we'll do the same thing, but with for loop. So I'll create one ec2.tf. So you know the syntax generally, resource, AWS underscore instance, and you can give the name. For example, I'm giving RoboShop. and AMI equal to. So we will always create variables dot tf. Okay, and then let me copy that. Using conditions. Okay, let us take this variable. This is the AMI ID. Dot AMI ID, and then instance type. For example, t2.micro. So how you get this documentation is terraform.io. Here you will have registry. So inside registry, you have providers and AWS provider, and you can go for documentation. Here you can just type AWS instance. Okay. So this is the full documentation. So now I just want to print the entire information we will get once the instance is created by Terraform. Okay, let us print the info, AWS instance info. I'm printing, okay, value equal to AWS underscore instance dot roboshop. So now I don't want to print a particular public IP or private IP or something. I just want to understand what is the information I'm getting when I create the RoboShop instance. Okay, so now let us see this Terraform plan. Var.ami. I didn't save. So sometimes we do the mistake. We will update the file, but we don't save. Then you get error. So just understand you didn't save. Terraform apply auto approve. AMI does not exist. Maybe I'm using different region. This is US East 1. The instance is getting created. Okay, it is done. Now, if you see the output, this is the output. Okay, let us copy this. This is the full output. Okay. So if I paste here, So you can understand what is this data type. Can someone please type in the chat? What is the data type? Is this string? Is this list? Is this map? Is this number? Is this boolean? What is the data type? Yeah, this is JSON. But if you just think this is a map, okay? This is not a list. List always starts with the bracket like this. Map always start with a brace like this. So this is the key. AWS instance info is the key, and this is the value generally. Okay. But if you consider this on a whole, this is the map. Inside this, again, you have key value pairs. Okay. So I just want to tell you, so we will get all the information from this. If you print like this, you will get each and every information. AMI ID, whatever you have given, the ARN, public IP address, and yeah, all the information you can check here. Okay. Public IP, private IP, DNS. So everything you are getting here. Okay. Yeah, security groups and the subnet, everything you are getting here. So now let us proceed. Just keep, just may understand this. Okay, now inside variables, I want to create 10 instances. Okay, so you know the condition here for our RoboShop. For just MongoDB and MySQL, it is t3.medium. For others, it is t2.micro. So I can keep this information in map. So that is just like instances. And here, I can create a variable. So that is of map type. Map. So what I will keep here is default equal to map starts with flower brace already. So if it is MongoDB, I want to create t3.medium. So this is an use case to demonstrate for each. Okay, you can do either count or for each. So this is t3.medium. Okay, so remaining all like Redis equal to t2.micro. And then RabbitMQ, catalog, user, cart, shipping, payment, web. Okay, so this is RabbitMQ, and this is catalog, and this is user, cart, and then shipping, payment, and web. Okay, so this is what this is the map I'm just giving. Okay, so now I need to iterate. I need to iterate is nothing but I need to loop. I need to loop over this map to create the instances. Okay, so now the for each syntax of Terraform is Terraform for each. Okay. So you need to give the map what you are iterating. Okay, so just like count equal to you give 10, right? So here you will give for each equal to var dot instances. So it means you are telling Terraform, I'm going to iterate for loop over this var dot instances. Now you will get one by one. First time you will get this one, second time you will get this one, third time you will get this one until all the entries are over. Okay, so that is the for each. So for each equal to what is your set or what is your map generally. Okay, that is the basic syntax, and so it will make one special variable available that is each. For each, when you iterate over a map, it will give us one special variable. It will give us one special variable. So that is each. So variable name itself is each. Now you can get each dot key and each dot value. So for the first time you are iterating, this is each dot key, this is each dot value. Second time, this is each dot key, this is each dot value. Third time, this is each dot key, this is each dot value. Okay. So now instance type, that is nothing but what is this? Each dot value. Okay. And then let us give that tags equal to name equal to each dot key. That's it. Okay. So you are iterating over a map and you are storing instance name and what is the instance type in this map. So using each dot key and each dot value, you are creating the instances. This is for each. Okay, this is also one type of loop, right? So let me comment this. Now, if you plan, you will get all the instances. So previous instance will be deleted because I updated. So now 10 instances to add, 1 to destroy. So now let us apply auto up to. So all the instances are getting created. So now the same for each, we can apply for our Route 53 record also. Okay. Let us get the documentation. If you don't know what is the name of the resource, you can just type Terraform Route 53 record. Okay. So we are first getting Terraform modules, it's fine. You should get this documentation actually. Getting modules. You'll see the modules topic that is little advanced. Okay, so this is the resource type, and then you can just search this with this documentation here. Okay, AWS Route 53 record. So this is the syntax, basic syntax, and you can see you can always have more options available. Okay, you can go through the documentation whenever you need. So now this is the AWS Route 53 record, and the zone ID generally we have where dot zone ID. So if you just declare variable here, obviously you should declare here as well variable zone ID, and then default. What is our zone ID? So this is the ID. Okay, and what else? Your So again, I need to iterate here because I want to create 10 records for underscore each var dot instances. Okay, so now here, so you will get each keyword. I want to get each dot key. So this is join DevOps dot online, right? So, but if you are using variable with this, you should always keep double quotes. And then here it is dollar, this one. So this is called interpolation. When you are using variable with a text or string, you should always keep the variable separate like this. Okay, and you can keep this one as var dot domain. Okay, so what is our domain name? Variable domain default equal to join DevOps dot online. Okay, so you are getting this is going to be iterated for 10 times. I'm getting every time each dot key. TTL, I'm keeping it 1 second. Now here the IP address. So we have a condition here. If web give public IP or else you give private IP. So this is the condition, right? This is the condition. How you get the condition here? Again, so the same condition syntax. Each dot key equal to web. Okay, question mark. Then each dot value each dot value. So each dot value, what is the value? Here we have given this is instance name. Okay, sorry. I have to iterate over this one. So why I have shown you this one is how you are getting info. So what is the iteration here? AWS instance dot RoboShop. Okay. So before I do, I will show you that as well. Okay. Output. AWS instance dot RoboShop. Now we will see. Earlier we created only one instance. You got a big map. Now I'm creating 10 instances. Again, you will get a big map. So that is, let us see this. So this is the whole instances we created. Okay. Because this is 10 instances output. This is the entire output. If you see, what is that key? Your instance name is the key. Can you just check? So your instance name is the key and it has the map structure. You can get any information you want. So like this here, we have information of private IP or public IP. So now I need this information. So here, so each dot key, I will get for example, for the first time, I will get web.joindevops.online and each dot key is web. So what is the value I want here? Each dot value, each dot value dot, this is the value. Just understand. Okay, so this is the key. So this is the value. I don't want everything inside that. I want only public IP. So then I need to give each dot value dot public underscore IP. Okay. If it is not equal to web, what is the information I want? Each dot value dot private IP. Okay, that's it. So actually just for demonstration purpose, I printed, but you should not print this much information on the terminal generally. Okay, so that's it. Now the records will be created. So every time it is looping, it will check if it is web, I have to give public IP, otherwise I need to give private IP. So now let us Terraform plan. Something wrong in line number 14, 15. Oh, sorry. This comment. Okay. So what is it saying? Because I commented outputs, right? So obviously it is going to delete that output. It is creating records, 10 resources to add, and then it is removing the output. Now, Terraform apply auto approve. Okay, now the records are getting created. You can just check. So we got the records only for web. We got public IP, remaining all private IP. So this is how you can use for each, just like your count and count index. So now we have one more loop that is dynamic block. Okay, so till now the count or for each is to create more resources with single syntax, right? So this is the purpose why we are using loops. Instead of creating 10 EC2 instances like this, we are just using one resource definition to create 10 based on the loop. Similarly, inside the configuration, just let us take the example of, let me take the example of security group. Okay, so here let us go to the security groups. I want to create a RoboShop security group. Okay, name is RoboShop I'm giving. Okay. Allow, for example, HTTP, HTTPS as such ports. Okay. You will create inbound rules. Here you will say SSH, and you will say this one, and then HTTP. Generally in production environment, we'll do like this. We will not allow all the ports. We will allow particular ports, HTTP, and then 0.0. So like this, I need to create 3 ingress rules. So if you have to do that through the Terraform, what you can do here is AWS underscore security group, Go to the resources. So security group, not security hub. This one under VPC. Yeah, so this is the security group. So this is the syntax, right? Now let us modify this syntax. Okay. I'm giving a name, for example, something like RoboShop, and name is the name we have given here. Yeah, RoboShop is given, and the same RoboShop. You can always keep them in the variables also. And here you can write the description, allow HTTP, HTTPS, and SSH. And VPC ID, you can, if you don't give by default, it will take the default VPC. Now I need to create 3 blocks. One is for 443, one is for HTTPS is nothing but 443, and another one is for 80. So this is for 80, and this is for 22. So generally in production environment, you will have to give the rule for each and every port. Okay. Maybe sometimes we will have 10 ingress rules, sometimes we will have 20 also. Okay. So at that time, you need to repeat this code for 20 times. So you can see this is the configuration inside the resource definition. Now just understand. So count and for each, generally these loops you will use to create the entire resource itself. But dynamic block is a special. It will be used to create multiple configuration blocks inside resource definition. Okay, not the entire resource itself. If you are getting a repetitive configuration inside, this is the configuration block, right? So inside resource definition, if you are getting a repetitive configuration, you can use dynamic blocks for that. Okay, so that is the advantage of dynamic blocks. Okay, so I cannot keep this 20 times. So instead of that, we can go for dynamic block. So the Terraform dynamic block, Terraform dynamic block, if you search. So here you can see within top level block constructs like resource expressions can be usually okay. Some resources include repeatable nested blocks in their arguments. Okay. So for example, this setting, this block should be repeated multiple times. So in that case, you have to use dynamic block. Similarly, here, this ingress has to be repeated multiple times. So in that case, you can use dynamic block. So you'll get this question, what is dynamic block in Terraform? You can say dynamic block is used to repeat the configuration inside the resource definition. Okay, so just like for loop or for count is used to repeat the entire resource, but dynamic block is used to repeat the particular configuration inside the resource definition. So that is the answer you can give. Okay, so now let us understand the syntax. Okay, so wherever you need, you have to give dynamic keyword. For example, now here I need, this one has to be created multiple times. Now I need to give dynamic here. Okay, so this is the syntax, and then inside that you need to give for each, because you need to create a loop. So here I need to give for each, and then you need to give the variable where it has to loop, and then the content, which content is getting repeated. So this content is getting repeated. So in that case, you need to give content and keep this content inside. So this is the syntax. Okay, so by seeing this, you should understand. So this ingress block is going to be repeated, and this content is going to be also repeated. Okay, you are applying dynamic for this ingress block, and the content is this one. Now you need to have for each for that. Okay, so again, you need to create a map here. So I'm going to create variable and then ingress, okay, type equal to map and then default. So this one, what is the type here? So this is, sorry, this is list actually. So this is list. You apply for each, then first time you'll get this element, second time you'll get this element. So inside here, I'm giving from underscore port equal to 80 to underscore port equal to 80. And what else we require here? From port to port. Description is optional generally, but you can keep it. Protocol, we don't need IPv6. We are not working on IPv6. We need these 5 values, for example. Okay, so you need to keep them inside this from port to port description, allowing port 80 from public, and then protocol, that is TCP, and CIDR blocks is this one. Okay, so this is one entry, and similarly you have to keep entries for 443, 443, and allowing port 443 from public, and again one more entry, port 22, port 22, port 22, this one. Okay, so like this you have to create a variable, and here var dot, sorry, not instances, ingress. Okay, you can remove these things. Okay, and I'm giving name as RoboShop. Okay. Sorry, keyboard batteries are over. I'll just come back in 1 minute. Okay, so I'm just giving as RoboShop. So that's it. Okay, so whichever content you want to repeat, you have to give dynamic, and for each is mandatory inside that because it has to understand from loop, and then this is the content. That's it. Now you can go for Terraform plan here. Managed something error. Reference to undeclared resource. So it is actually CID or block, but the variable we have given there is CIDR blocks. Okay, and this is correct, right? This error line number 12, managed resource AWS underscore VPC main has not been declared. Some problem here. Yeah, I need to give this var dot CID or blocks. Okay, that's it. Now you plan. Okay, this is not var, this is each. That's what we say, right? Okay, sorry, not at all, not even each. So here I forgot to say one more thing. So this for each, here you will get a variable ingress. So whatever you give here, so this for each make the values available with this ingress. Okay. So ingress. So this is the variable just like each ingress dot and then value dot. So this may be a little confusing, but it's fine. So this is the value for the first time. Inside that you have to give from port. Okay. What is this? Ingress dot value of, till that's a map, you need to select this one like this. Okay, can just see the documentation here, dynamic setting. Then it is getting setting dot value. Okay. Similarly, the dynamic keyword is ingress. So you will get the variable ingress. Ingress dot, you will get for the first time this one. You'll get for the first time this one because it is iterating. So inside this, you want from port. Okay. You can keep ingress dot value. You can keep like this also. Generally, you can keep like this also. Let us test that anyhow. And sorry, this is description. Description. This is from port. This is to port. This is protocol. This is CIDR blocks. So this dynamic block, generally it is confusing. Mostly we don't use, except in few cases like security group. If you have more uh, content to be repeated, don't panic. You can always go for Google and then search it. But just understand the purpose why we are using dynamic block, at least for the interview purpose. Okay, so now let us go for plan. Okay, now you can see you are getting 3 blocks repeated. Okay, either you give like this or you give like this, that's fine. Terraform, apply, auto approve. Okay, now you are getting actually. So let us just refresh this. You got RoboShop, and here you can see you got the 3 inbound rules. Okay. So this is how you can use dynamic blocks. The next concept is very important: state and remote state. So till now you learned how to write Terraform syntax to create the resources like variables, outputs, data sources, locals, and then conditions, loops, count index, everything we learned. Okay, now we know how to create the resources, but you have to understand how Terraform is creating the resources. How is it understanding we are doing some change? How is it understanding we are commenting, so it has to delete? So how Terraform is all understand. So that is because of the state and remote state. This is very, very important topic, not only for understanding, for interview as well. So what is Terraform? So it's a declarative scripting that can create resources based on TF files. Okay, so now here declarative is, I am giving declaration to Terraform. Now it is Terraform responsibility to create resources, whatever you write in TF files. Okay, so TF files is nothing but declaration. So I'm giving orders to Terraform to create infrastructure. So that orders is from the TF files. So this is declaration. And that is nothing but ordering Terraform. So now Terraform started creating. So this is called as state. So state is nothing but Terraform has to know what resources it is created. Okay, so that is nothing but through terraform.tf state. So if you see, you have something called terraform.tf state. Can you say this? So at every point of time, whenever you are creating some resources, Terraform make this available. Terraform.tf state is the default file available in your folder whenever you are creating resources. Now, these are the resources created by Terraform. Now you can see AWS instance, RoboShop, and the instances it created is cart. So this is one instance. And the next instance it is created is catalog and MongoDB and MySQL, payment, RabbitMQ, Redis, shipping, user, web. So these are the instances it created. And then again, it created Route 53 records, cart, catalog, MongoDB, MySQL, payment, RabbitMQ, Redis, shipping, user, web, and then it created security group. So in that security group, this is egress, and then this is the ingress. So Terraform is maintaining terraform.tf state. Okay. Terraform.tf state equal to Terraform will see this file to understand the resources it created. Okay. So now the Terraform responsibility is TF files should be equal to terraform.tf state. So this is the ultimate aim of Terraform. Whatever you are writing, so that should be created. When you create, when Terraform is creating the resources, it should understand what resources it is created. So that is why it is keeping terraform.tf state. Now, for example, I am commenting this. Okay. For example, I'm commenting this, or let me comment this one. So now there is a difference between TF files and then terraform.tf state. What is the difference? So now TF files don't have egress. Okay. But terraform.tf state has egress. So now what is the Terraform responsibility? If you do apply, can someone please type? Or if someone wants to tell, you can raise your hand. Yes, Murali Chen.
To create instances.
Now I'm commenting this one. It means I don't want this egress, right? But terraform.tf state has egress. So now Terraform responsibility is to delete egress. To delete egress and update terraform.tf state. Because the ultimate thing is this one, TF files. I'm the user, I'm the owner. I'm the one who can declare. So I'm declaring I don't want this. So now when you plan, you can just see what Terraform will do. Terraform will compare the TF files and then terraform.tf state. I didn't save this. It's not validating at this level. It should generally, but fine. Let me take this for the entire security. Okay, sorry, this is not considered actually. So if you want that to consider, you have something separate inside security group. You have separate resource actually, that is egress. AWS security group. And there is a thing called egress. You can see egress rule. Okay, if you want that to be deleted, generally you have to delete. But yeah, so this is at the resource level, not inside the block level. Okay, let me now plan. So you are saying Terraform, I don't want this one. Now Terraform will compare this TF files and terraform.tf state. Now it will understand, okay, I have created the security group earlier. Now the user don't want, so I need to delete that. So one to destroy. How it is understanding by comparing the Terraform files with terraform.tf state. Now if you apply, it will delete and it will update the terraform.tf state as well. Now you can check here, there will be terraform.tf state.log info. We will understand this. Now I'm not able to open terraform.tf state. Why? I'm not allowed to open because Terraform is creating one log file here. When something is going on in the background, 21 to destroy. Okay, so am I commented this? What happened? Did I do something wrong? It is destroying everything. This is fine. Oh, I ran destroy command. Sorry. So it is destroying everything. For example, anyhow, I asked to destroy, it is destroying. But while doing this, you can see there is terraform.tfstate.log info. It means Terraform is doing something in the background. So you are not allowed to open because Terraform is working on it. So that is why it is creating .log.info. So you will get this interview. What is Terraform state log? So you have to say, but Terraform is working on something in the background. We are not allowed to open terraform.tf state because it is doing the updates to the terraform.tf state file. So it will make one log file available. If this log file is available, you cannot open. Now the log file is gone. Now you can open. You can see we don't have anything here. Okay. So anyhow, let me create once again. I just gave destroy. So now understand the difference again. It don't have anything here. Now I'm asking to create. So what it has to do? It has to create everything. Now again, a log file will be created. You can see, and I'm not allowed to open. You can see I'm not able to open because Terraform is working on this TF state file. It is creating the resources in the background till it completes a job. We are not allowed to open because of this log file. Okay. So now let us frame the answer for what is Terraform state. So you have to tell like this. Terraform is a declarative scripting. Terraform responsibility is to create resources declared in TF files. Terraform will create terraform.tf state file to understand the resources it is created. So all the time, Terraform tries to match TF files with terraform.tf state, with state file. Okay, So you tell this answer, and then all the time Terraform tries to match the TF files with state file. And then you can say an example. If we comment one resource, then Terraform will compare the TF files with state file, and then it will understand to delete the resource. Okay. So I hope this is clear. Now let us see. Now let me comment this. Oh, this is already commented. Let me uncomment this. So now I added one more resource to the TF file, but terraform.tf state don't have that AWS security group. Okay. So now when you give Terraform apply, okay, it will read all these TF files and it will compare this with terraform.tf state. Then it will understand, okay, I haven't created security group, so I need to create. Okay, let us plan this list. You can see it is first refreshing the state. State is nothing but terraform.tf state. So it is understanding from the state, what are the resources I have now. This is refreshing. And then now it is going through the TF files and it is giving us some difference. Okay, in the state file, I don't have security group. Now the user is asking security group, so I have to create. So I'm giving one resource to add. that is how it is understanding. Now, if you apply, it will create and it will make an entry inside the terraform.tf state. Okay, now it added the resource. Now, if you apply again, obviously there are no changes. So then it will understand TF files and terraform.tf state both are in sync. So there is no change to the infrastructure. Okay, there are no changes because both are equal. So that is how Terraform will understand the either creation or updation or delete. So this is terraform.tf state. It is very crucial and it will make one TF state backup for the security purpose. For example, this is very crucial, right? By mistake, if you do some edits here, generally users are not allowed to make manual entries or updations or deletions in this file. Okay, only Terraform is allowed to do the changes. But by mistake, if you do some changes and if you corrupt this file, you always have one backup file. Okay, so that is the purpose of backup. At least you can go one step back in your infrastructure. So as a backup purpose. So terraform.tf state, terraform.tf state.backup, and terraform state log file. Terraform state log file is available and Terraform is doing some updates in the background. And this backup is available as a backup purpose if the current state is corrupted by the user. So you always have the backup file to go one step back in the infrastructure. Okay. So now you should understand terraform.tf state is very crucial. You should not mess with it. Okay. So if you see our git ignore, we are ignoring this one. So we are not allowed to push TF state into the GitHub. So it's a security. You are pushing your entire information into the GitHub. That is not good. Okay. And let us understand another thing called remote state. So we have few serious problems if you keep state file in the repo or local folder. Okay, what are the serious problems? First, let me push this. Okay. So we have this. For example, just understand DevOps engineer 1 joined and DevOps engineer 2 joined the company, 2 joined the project. So what they do? So engineer 1 in his laptop, he will clone the code. Engineer 2, he will clone. So both started working on the repo. Okay. First, let me destroy this. And let me destroy. For example, excuse me. So this is PC. Here I am creating 2 folders. Engineer 1 and engineer 2. Just imagine these are their laptops. Okay, different laptops. This is engineer 1 laptop. What I'm doing here is, let me take another window. This is engineer 1. Okay, I'm cloning here. So he is cloning the code because he just joined. Okay, so completed destroying. Okay, let it complete. Completed. MongoDB is still destroying. Yeah, it is destroying. So now engineer 1, he joined. So we gave him a task to create the infrastructure. Okay. So what he do? He will go for Terraform init for the first time. Similarly, let us take one more window for engineer 2. cd/engineer 2. Okay. And then he will also clone. Oh, it clone. So he will go to the Terraform for each. Okay, initialize is done. Terraform plan. Since it is taking more time, we have a lot of resources. I'm going to comment few resources, right? Let me comment this. These two. Let me comment because this is taking a lot of time. We have to wait. So now again, Terraform plan, engineer one. So he got a task to create the security group. Then I didn't save it. Oh, I need to push, sorry. So we are pushing. Okay, now engineer one is going to pull. And engineer two is also going to pull. Okay, so now engineer one got the task of creating the infrastructure. So Terraform plan. Okay, Terraform apply. So now what will happen generally? Terraform dot tf state will be created. Okay, one is getting created. Now let us check. So terraform.tf state is created. It has the information of the security group. Now this is not known by engineer two. What he is doing is he is also going for Terraform plan. Okay, Terraform init for the first time. Okay, now he is going for Terraform plan. It is saying one resource to add because it don't have any terraform.tf state, right? So then it is understanding the Terraform in engineer 2 laptop, it is understanding, okay, I don't have any terraform.tf state. This is the first time I am creating the infrastructure. So I have to create the security group. Now he will go for Terraform apply auto approve. So now it is adding one. So now he got an error. What is this? Duplicate. The security group RoboShop already exists for VPC because engineer one already created. But engineer 2 laptop don't have any information because terraform.tf state he is keeping it in his local. So this is the problem. So now let us understand through the diagram. State. So this is his laptop. he has Terraform in his laptop, and he has his own state. So this is the state. So this is another laptop, and he has also Terraform. He has also state. So this laptop created security group in AWS account. So this laptop created this. When it is trying to create, AWS is throwing an error. The error is from AWS, okay, not from Terraform. AWS is throwing the error, then Terraform is showing us the error. Why? Because this is already created. Still, this laptop is trying to create because this state file don't have any idea of what is there in the AWS account. Okay, so this is the problem if you keep the state file in your local. The problem is either you get an error or you will get duplicates. Okay, so duplicates how you will get generally. So let me uncomment this. Let me uncomment this. And this one, okay, let me uncomment that. And then we will push. And this guy, he is pulling. This may get an error generally. Let us try. Fine. And he is also pulling. Okay. Now he's applying. Engineer one is applying. So when engineer one is applying, you will get the instances. Okay, you can see you are getting the instances. And similarly, engineer two is not aware. Maybe he is also applying. Okay, he got 11 resources to add 10 instances and one security group. Now let us see what is happening here. So this is also creating. Engineer 2 is also getting created. I mean, engineer 2 instance is also getting created. So now if you see running, you can see you have the duplicates. MongoDB, MySQL, payment, and the remaining instances are getting created. You see, you have all the duplicate instances. So there is a problem. Why? Because the problem is occurring. Why? Because the problem is occurring. This local state don't have any awareness what is there in the AWS account. Okay, because this Terraform is comparing with this state. This Terraform is comparing with this laptop state. So we have two problems. Either you get duplicate resources or you get error while creating resources. Resources saying already exist. Okay, so this is the problem. So for this problem, what happened here is, so we got something called remote state. Okay, now you don't keep the state in your laptops. You have Terraform, and this laptop also has Terraform, and this one. Okay. So now the remote state is nothing but you don't keep the state in your folder or in your repo. So you will keep the state in central location, remote state. So since it is not local, we call it as remote state. So now when laptop 1 creates something, it will store the state here. Generally, this is S3 bucket, generally we call it as, it will store here. So it will store in this. When laptop 2 is trying to create the infrastructure, it will compare this with this remote state. Okay, then it will understand, okay, the resources are already exist, then there is no point of duplication. Okay, let us see this. So this is very important to understand generally. This is why I'm taking so much time. So here also I'm destroying. So just understand, we have to keep the state somewhere inside the remote, not in your laptops, not in your repos, something. So we have the remote state option that is from the S3 bucket. Okay, so you keep your state file here and lock with DynamoDB. So you'll get this question in interviews. What is the state and remote state in Terraform? Then you have to say state is nothing but Terraform has to compare the declared configuration versus the actual configuration. I mean the existing configuration, so that Terraform creates a state file for comparison. But if you keep state file in your local or in your repositories, there is a problem of duplicates or errors. So we have to keep the state inside a remote location. Then this will be very useful for the collaboration purpose. Okay. So now the syntax to keep the Terraform remote state is Terraform remote state. Okay, you need to keep it inside S3. So you have to mention backend. So the syntax here is go to the provider. Here there is something called backend block. So inside backend block, I'm keeping it in S3. Okay, the syntax here is what is the bucket and what is the key. So this key is nothing but I'm going to keep it as for each demo or for each demo. So that is the name of the state file and then the region. Okay, first I need to create the bucket. Let me create the S3 bucket. S3 bucket is nothing but some storage. Understand, for now it is storage. Go to S3 here and then it will list down all the buckets. Okay, I'm making it as RoboShop remote state. Okay, so this should be unique name across AWS accounts. Okay, so if another account has the same name, then you will not get that. For example, let me give remote state. Just like DNS, it should be unique. If you try to create, you'll get an error because someone already took this name. So you should always give something unique. RoboShop remote state. Let us check whether this is available or someone in the internet already used it. Okay, this is available. RoboShop remote state. This is the bucket. Just give this bucket name here, and it is in North Virginia. So you have to give the region also. region equal to US East 1. So we need locking mechanism as well, because when one person, engineer one, is creating the infrastructure, doing something on infrastructure, others are not allowed to do that. So for that purpose, we need locking mechanism. So in AWS, the locking mechanism is from DynamoDB. So just search here, DynamoDB. Don't worry, you don't need to understand the what is DynamoDB, everything. You will understand it later. So you will have DynamoDB. So inside here, create table, RoboShop lock. Okay. And the partition key should be like this, lock ID. Then that's it. Okay. Create table and the partition key should be in this format, lock ID, exactly same. Now you have syntax with Terraform remote state with locking. Just get the syntax. This is guy, right? State locking. Just giving syntax. You can see DynamoDB table. This is the syntax. DynamoDB table. So what is the table name here? This one, RoboShop locking. Okay. So now you are telling Terraform, don't store the state in local. Okay, don't store here. Destroyed. Okay. So now you are telling Terraform, don't store the state file in local. Keep it. Backend is nothing but remote storage. Okay. Keep it inside a bucket, and that is in US East 1, and lock that with this DynamoDB table. Okay. So this is what you are telling. Now let us push. And engineer 1 is pulling. Engineer 2 is pulling. Now he tries to create infrastructure. So what we said, so we are changing the backend initialization. So you have to run Terraform init, because you changed it. You have added S3, so you have to init. So similarly, here also you have to init Terraform init. Okay, now he is applying. You can see acquiring state lock. So this is creating the lock in DynamoDB table. You can just go and then check here. Explore table items. Now you can see this is the lock created. So it is creating the infrastructure. At the same time, maybe this guy is also trying to create. So now this Terraform will compare this with the remote lock. Now you can see error acquiring the state lock. Terraform acquires a state lock to protect the state from being written by multiple users. Please resolve this issue. And so it is saying, so already the log file exists here. It means somebody is working on that. So I cannot able to create the resources until other user completed. So that is the safety. Okay, let it complete. So till this one I completed, you cannot, other engineer cannot do any changes. This is the security. So now the first point is done, right? There is no duplication, there is no errors. Okay, so this is done. Now let us run Terraform apply for the second user. Now what does it say? Why is it saying no changes? Because it is comparing with the remote state. So this guy already did something and it is stored. When the second guy is also doing, it is comparing with remote state and it understood I don't have any changes because already it is there. Okay. So now for the three reasons, duplication, errors, and then accidental changes. So now users don't have the terraform.tf state in their local, so there will be no accidental changes or accidental updates or edits. So this is why Terraform remote state with DynamoDB locking is always preferred in AWS environment. So the answer is, if you keep the state file in local, there may be a chance of duplicates, errors, accidental changes. So we keep the state in remote location like S3 and lock it with DynamoDB so that there will be no duplicate resources, no errors while creating the resources, and then no accidental changes. So from next session onwards, we will keep the state in S3 and lock it with DynamoDB. Now you can go to S3 and you can see there is a key for each demo. This is what the key we have given. Download it and then you can check. Now you can check. The state file is here. Okay. Whatever the key name you give, it will be stored inside the S3 bucket. So we can stop till here today. Let us have some questions. Arvind?
It's cleared.
Yeah, okay, thank you. Chandrasekhar?
Hi, good morning, sir.
Yeah, hi, good morning.
Is that Terraform is case sensitive?
Yes, maybe.
Yesterday I tried using name. The tags is there, right?
Oh, that is okay. That is not case. The tags is just name. Either you keep it capital web or small web, it is same. So if you talk about this resource names, then it is case sensitive, like this one.
In the tag there is a name. N is capital letter is there, right?
This is, yeah. So this is from the AWS actually. Okay, you can see here. What is this? This one, name. If you
Yeah.
give small name here, then that tag will not work.
Okay, that it means it is not case sensitive as per in
See, nothing
Terraform.
is from Terraform. Nothing is from
Okay.
Terraform. Everything is from AWS. Whatever AWS is telling to Terraform, it is conveying to us. Okay. If
Okay.
AWS is saying it is completed, then Terraform will say us the resource is completed. If AWS is giving error, then Terraform will give us error.
Okay. Thank you, sir.
Okay. Yeah. So any other questions? So if you don't have much time to do this, you don't need to try like this, engineer one, engineer two. Just take it as granted. Now you already saw that. So keeping the state in the local or repos, it is a problem. We have to keep it in central location. Just understand that context and then perform it in the interviews. Yes, Sheikh Ahmed.
Yeah. Hi, Shiva. Good morning.
Yeah, hi, good morning.
So actually, yesterday I missed the class, so due to that, I think I didn't understand much. But regarding these TF files which you are creating in Visual Studio Code,
Mhm.
can we? Yeah. So, so what exactly the TF file we are comparing with the state file? You're saying variables.tf?
Not variables, these resources, resource definitions. The variables, those are not resources actually. These are the resources we are creating in AWS.
Okay, so
Yeah,
EC.
this resource.
Okay. So these EC2.tf, provider.tf, sg.tf, all these have you given a small definition regarding this already in
Yes,
yesterday class? Okay.
yeah. So provider.tf, we already know this from the first session itself. Yeah.
Okay, yes. So these.
Okay. Yeah.
Yep.
Thank you so much. Suhail?
Yeah, hi Shiva, good morning.
Yeah, hi, good morning.
Shiva, I have one query. I mean, you are pushing right to GitHub. First of all, we need to initialize to Git right before pushing the existing repository.
Yeah, I already did that. That is Git init is different. So Git init is different, Terraform init is different.
Okay. But if we want to, I mean, push to Git, we need to initialize, right? With, I mean, the local repository with the Git.
So already I initialized. That's why you are able to see here master.
Okay. I mean, after that, we need to create repository, right? I mean, after initializing, we need to create a repository in GitHub, and we need to add git remote, add origin like that.
Already repository is created. You can see it is master. Why you want to create again and again? You are
Okay.
able to see this one. This is already created. No need to create every time.
Okay. Okay, sure. Understood.
Yeah.
Thank you.
Santosh Avula.
Yeah, hi Shiva, good morning.
Yeah, hi, good morning.
Yeah, Shiva, I have the one doubt. So in today's class, you have to unexpectedly run the destroy command, right? Okay, suppose we have to run same like in a production environment. How you get back of the again? We have to save infrastructure.
Then you need to apply again. Generally, you have to go for plan and you need to check the plan. Then only you can go for apply or destroy. Okay. So before I run destroy, if I have given plan, but that is by mistake, I ran destroy.
Yeah, I asked.
So generally, we don't do manually. We will do it from Jenkins anyhow. So at that time, you will understand through the pipeline.
Okay.
Okay.
Yeah, thank you.
Nisha?
Yeah, hi Shiva, good morning.
Yeah, hi, good morning.
While I'm already I have tried yesterday's all the sessions. While I am trying to comment out the script, but I can't able to comment out by selecting all the script. I am trying to comment the lines, but I can't able to do.
This is just toggle comment. What?
Yeah. By selecting all the script and I am trying to toggle line comment, I can't able to do. Block comment also I have tried, but
yeah,
I
you just
can't
try
able
this, bro. This is okay. This is not something related to Terraform. Just try this multiple times. Okay.
But is there any plugins? Is there?
No plugins. By default, it is the default from VS Code. Okay. So in that case, you go for generally manually. Just try something in Google.
Yeah,
okay?
in Ansible, in that kind of script in playbooks, I can able to comment out by whole script I'm selecting and commenting out.
Maybe install the extension of Terraform.
Yeah.
Install the extension of Terraform.
Oh.
So otherwise, maybe VS Code will not understand. This is really Terraform, how to comment. VS Code may not understand. Install the extension. Okay.
Okay.
Yeah. So if some of you are completing the session, you just give me a timestamps like this. Huh?
Hi Shiva.
Yeah. Hi.
Good morning, Shiva.
Good morning.
Shiva, you are keeping T2 micro and T3 medium instance types, right?
Yeah.
So my doubt is, in real time, are we directed to keep some instances like T2 micro by developer or team leader, or it is our wish to keep?
No, architects will decide. Architects will decide.
Okay.
It's not our wish.
Okay. Okay. That's my doubt. Thank you.
Okay. Yeah. Most welcome. So if some of you are completing the today's session, just give me the timestamp like this and send me a message in Slack. I'll update in YouTube so that everybody can see at what timestamp, what topic we discussed. Thank you so much. Have a nice day. See you on Monday. Have a nice weekend. Just try to complete these Terraform concepts. I see you.